In this problem, you recognize a quadratic type, x squared and x to the power that's double that, so we can use u substitution. If we let x be, or u be x squared, therefore u squared will be x to the fourth, and we can substitute that in. U squared for x to the fourth minus 65u for x squared. Now we can look to solve this by factoring. So here, since our leading coefficient and constant are not prime numbers, I'm going to go ahead and multiply them. 16 times 4 is 64. Two factors of positive 64 whose sum is negative 65 is negative 64 and negative 1. So I'm going to rewrite my middle term as the sum of those, drop down my first and last terms, and factor by grouping. So from the first pair of terms, I can remove a 4u, leaving a u minus 16. And from my second pair of terms, there's no common factor, so I'll just take out a negative 1, leaving u minus 16. I have a common binomial factor, u minus 16, and my factors of 4u and minus 1 become the terms of my other binomial. And so I can set each of these equal to 0. U is equal to 16, or u is equal to, we take the opposite of the constant, positive 1, divide by the leading coefficient, 4. Okay, the final step is to substitute back in. We know that x squared is equivalent to u, and we extract the square root to solve for x. We get x is equal to plus or minus root 16, which is 4. X squared can be substituted in for u, 1/4. Extract the square root. We get x is equal to plus or minus the square root of 1, which is 1, over the square root of 4, which is 2. And so here would be your 4 solutions.